everyone, and welcome back to the Internet Report's Pulse Update, where we keep our finger on the pulse of how the internet's holding up week over week. This week, we'll explore a ChatGPT outage, Microsoft's update on recent subsea cable cuts, a tax day H&R Block Outage, and more recent incidents. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to like and subscribe. And for all our YouTube listeners, don't forget that we also release this show on all the major podcast platforms, so feel free to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. On with the show, and I started by asking Mike to tell us what happened with ChatGPT.
On April the 10th, ChatGPT experienced this issue where users actually couldn't access the system. They were getting sort of degradation. It turned out to be errors due to a cluster problem. And when actually ChatGPT or OpenAI traced it back, they traced it back to a control plane service that experienced some memory exhaustion. So when they identified this, they saw this increase in errors, and that then allowed them to look to see how they could actually change things. They redirected traffic to a second cluster. So they have two clusters involved, which is doing all these requests. Now, when they actually directed the traffic to this second cluster, what happened then was it's actually unable to handle this more than expected request, i.e. it's actually been optimized to handle a certain amount of requests. And simply shifting it from one to the other sort of resulted in more errors and caused this degradation to occur even greater. So it wasn't a complete outage, it was actually a slowing down of services.
You said that one of the ChatGPT clusters suffered from memory exhaustion. Can you give us an explanation what that is and what knock-on effects that might cause?
So memory exhaustion is actually what it says on the tin. So the memory on the system is all used up. So when a program or a system runs out of available memory to perform a specific task, once the available memory is up, it starts to impact the other resources. It cannot continue to function properly. What actually causes it or what can cause it? It could be a number of things. So it could be something as fundamental as inefficient coding. It could be some other application running or some function running on there that's generating a memory leak, or just simply that this system is running too many processes at once. So they're all trying to use the memory up or use the memory to activate or to action their functions.
Rate limiting is a frequently used tactic when demand for services is high. Give us an explanation of how rate limiting actually works.
So what rate limiting is actually doing, it's actually applying queuing theory. So what we're saying is we need to control the rate at which we're getting these requests into a system. So if you think about this process, I don't know if you've ever been to the US, but where they take traffic onto the freeway, they have the traffic lights at the top. And it actually literally goes red, green, allowing one car at a time so that you can merge in the traffic and sort of move on. So that's really what we're doing here. So we're queuing the traffic at the ingress to the cluster itself and then releasing it as it goes through. So what we've done is we've essentially sort of removed the bottleneck on the cluster and we kind of pushed it back downstream, but we're allowing the system to sit in these ingress buffers and then we can process it in a controlled rate.
Damage to cables on both sides of Africa impacted Microsoft's network capacity in late February and March. Mike's been reading a recent incident report from Microsoft on the situation. What caught your eye, Mike?
This was a fantastic post-incident report they actually put out there. It went into great detail, and we're going to put a link in so you can actually sort of go through and read it yourself. But there's a couple of things that really caught my eye in there. So first of all, we knew about the fiber cuts. And we saw that and we reported on it. What they actually said sort of manifested itself, matched exactly what we'd seen from a ThousandEyes perspective, so what we saw in our data. So it was really cool to kind of sort of map those things back. What was really interesting, we obviously had this impact on the east coast of Africa. So that sort of took out some capacity. And then we had the west coast one. And we'd actually made this assumption that they sort of run out of capacity. But what it turns out is they actually run well, that's exactly what happened. But what also happened is it also coincided with an optical line card failure at the same time. So Microsoft, actually, the way they set up for this environment is they have 4 times redundancy. So they can effectively, it's like a jet flying across the Atlantic. They can effectively run on one engine, although you probably wouldn't want to be on that plane, but they can actually run on one engine to get across the Atlantic there. This is the same thing. So they could actually go down to one of their fibers or one of their paths coming up the West Coast and could have still handled all their traffic in that environment because they modeled to actually do that. And actually, after the East Coast cuts, they'd actually gone through this exercise where they modeled, what if we get a second cut? And actually worked out what they could actually do and had started to put things in place. So the fact then they had this optical fiber line card failure at the same time meant they effectively went down to 3.5 times they're available. So this is why we started to see these latencies, these packet loss, and these drops occurring there. We knew traffic in and out of this region was impacted. We could actually see this. We saw the degradation going to the various providers who are in there. Anybody who was relying on that capacity out of Africa or up the coast of Africa were impacted. We sort of saw that. And again, we reported on that in previous podcasts and blogs. What was really interesting was that some of the in-country stuff, so how they describe their architecture of the applications. So we'd think, for example, we talk about Microsoft 365. So we're talking about Microsoft Online. And because of data residency requirements, I expect my data for some of these organizations to be held in country. And it is, right? So they satisfy that completely. But the way the system works is there is also services outside of region that had to be called, that had to interact with it. Nothing of this was impacting the data residency requirements, but it was just the functioning of this application. So we always talk about distributed applications and relying on these different services. Now, this is exactly the case. So if I was within South Africa and I was trying to send an email to somebody else within South Africa, I would have expected that to be able to go through. But they were starting to see issues on that. And it was because of this third-party dependency within their own environment, they actually sort of had to make the call up. So they've taken this on board, and what they're starting to do is plan around this in the future. So it was just really interesting to sort of see this play out in real life.
The report says that Microsoft remediated the situation by switching the optical wavelengths on the Lagos branch. Can you explain what that means?
So what happened was they actually switched the bandwidth away. If you think about how these fibers are constructed, they're using optical wavelengths or dense wave digital multiplexing to ship the data up and down this path there. And this is all controlled by changing the wavelengths. So the branch comes off into Lagos in Nigeria. And what they did was they effectively switched the capacity away from that. So where we'd have had the traffic coming up that West Coast path and then going into Lagos, what they said was, okay, we're going to switch that off from there. So now this traffic doesn't go away. So effectively all they did was switch off the stub, the branch connection, as it were, coming onto that main path there. Now, as I said, it wasn't turned offline. They didn't take Lagos offline completely. What they did then was actually said, right, we're going to transport this traffic using an ISP, so a third-party ISP. They actually took this edge site traffic, went into the ISP, and then when they intersected with the Microsoft backbone again, they rejoined. So effectively did a bypass around the system.
It says something for Microsoft's resilience and planning that even with cable cuts on both sides of Africa, the company's network was never completely knocked offline in the region, doesn't it, Mike?
It really does. And it was really interesting to see and go through from there this forward planning. As I said up front, they're constantly doing these models. They're going through and understanding what's happening if a disaster occurs. The other thing I sort of found quite interesting from all of this was that they also acknowledged there's only so much you can do. They'd planned for 4 times redundancy, and it was effectively this perfect storm that caused the issue. They had the optical line card failure at the same time. Had that not occurred, then they would have been able to carry the capacity through that 4 times 1 capacity redundancy environment they had there. How they've architected the applications to meet this system, it did 2 things. One, it showed me, again, sort of how this resilience is there. We understand if we lose this, we can have some parts of the application functioning locally. We can shift stuff around. But also then, what we're always talking about, this complexity within the network, this complexity within our applications, the distributed architecture, distributed user base from there. But yeah, it's really good to see. Like I said, we've seen the resilience in the internet. We know things can route around it, but if I get some sort of failure at this critical path point there, it's really interesting to see then how the applications cope, how the data centers cope, and how they're able to continue.
So following on from our tax day conversation on the previous episode, we did end up seeing a disruption this year as some customers attempting to file their tax returns with H&R Block ran into issues. Can you explain what happened here, Mike?
The first thing to point out is actually restricted to H&R Block. And from what we can see, it was actually restricted essentially to the desktop software. So we'll talk about that being a thick client. So when you download particular software to run on your system as opposed to a browser. I point that out because what it appeared to be was the browser was actually working. I'll come back to why that's important later on. So what happened was when the users are trying to go through these various steps, they experienced 502 errors, preventing them e-filing their tax returns. It did appear to be restricted to thick clients, indicating that the actual problem lay with that. Now, the problem itself was sort of resolved after 4 hours. There was some alternative options. You can actually go into an H&R Block office and you can actually work with one of the brokers and they'll actually file your tax for you there. or you can actually do it through a browser. So you can log on to the application and do it that way.
A third option was to use the tax return data you had saved locally in the desktop software, print that out, and file by mail. But as Mike explains, the problem started when people tried to file electronically through the desktop client.
It appeared to be at that filing point was when the issue was occurring. So I could actually enter all my information in, and then when that needed to communicate with the back-end government systems effectively to actually do that filing, that is when the problem was occurring or the degradation was occurring and they're receiving these 502 errors that were stopping them filing their information.
Can you tell us what a 502 error actually indicates?
So a 502 is a bad gateway. So these are status codes that come back. There's a couple of things that these tell us. So one, this is anything that's a 5XX, so 503 or 502 or 500 that comes back to us. We know this is a server-side error. And the fact it's saying bad gateway, what it means is that I actually can't find my end destination. I actually can't communicate from there. But I've reached this system. So I've actually reached the environment there. And that then tells us we actually can't go on to the back end system. In this case, I can't go on to the third-party government site, which was the lodging it with the IRS itself. The interesting thing about that, though, is, again, this wasn't occurring when it was with the browser. It was only with the thick client itself within the software on the desktop.
Now we come to our outages roundup, a quick blast through a trio of incidents that Mike has noticed over the past fortnight. Let's start with Sky Mobile in the UK.
Sky Mobile experienced a service outage on April the 11th, and this was kind of similar to one we saw previously at another carrier in the US. So users are unable to access the internet or make calls, but only over the cellular network. So again, this only affected the 3G, 4G and 5G services. So it indicated there was a problem actually connecting into that handoff place again, so where we had the cellular connection coming in. We saw anecdotal evidence from customers who said when they turned off their Wi-Fi, they couldn't use it, which indicated that when they're on their Wi-Fi, connecting through the system, they could. And at the same time, we were able to look at the Sky Mobile internet backbone. And again, we saw everything up and functioning. We could get to their website and all this was there. Again, indicating the problem lay specifically within those cellular services themselves.
The next incident involved the CDN service, unpkg.
So several websites leveraging this free CDN service experienced an outage on April the 12th. It occurred around 8 a.m. UTC. How the outage manifested itself was we actually saw a Cloudflare error 520.
Cloudflare hosts the unpkg service.
The 520 error is specific to Cloudflare, and that sort of told us what's going on. Now, typically when you see this error coming back, it meant that the origin server can't complete the request. Now, this could be due to protocol violations, unexpected events, or empty responses. Typically, this error usually happens when a program or something like a cron job, so which is a command used for scheduling or automating a task, or a resource is actually taking up more resources than it should. So what happened then is they identified the issue, they started to do a fix. In the meantime, what some of the developers who are using this came up with the workarounds was to recommend to use another open source CDN that was using the same processes and sort of shift their stuff to CDN to keep their service up and going or their website up and going. The key to all this really is to really understand the components within your system. So the guys are able to identify the components within their environment, what they were using, and even before there was identified as error, were able to make this decision to move. They had the informed decision of where they actually to move for, and they can make a decision of what time they need to do it. So again, it's just constantly sort of drives home this point where we're saying is the end-to-end service delivery chain. If you can identify quickly where the problem lies, which specific component within the delivery chain it is, you've got the best option to what alternative do you want to use, or what backup, or what process, or what we want to instigate at that point.
The final incident in our roundup occurred at PlayHQ.
So PlayHQ is an Australian sports management company. Now, what they do is they actually allow you to enter your results, look at tables, download different game formats. So if you're playing a local golf competition, you can actually use that to sort of the format, the leagues, and these types of things. Now, they experienced this degradation on their site. It lasts around 4.5 hours on April the 13th. What happened in here is the users are actually experiencing 404 errors, and this actually degraded the system. So again, back to the point of 404 error, it actually tells us that the system's not found. So again, I can log on to the system. I couldn't retrieve the data. Again, this is another indicator, another signal that tells me what's going on. Now, in this case, the issue apparently was caused by a change in the mobile app's development, but this was deployed in January. So January 2024, they actually deployed this one and it kind of lay dormant up until that time. And it was triggered, we'll say, by an increase of load on April 13th, but it happened to be on a Saturday and it happened to be at the time where there was more competitions going on at once. So yes, it was low related, but it was also this perfect storm by these multiple requests and competitions coming in at the same time. So it kind of came in and sort of say hit this cache issue, and therefore then we couldn't find the stuff in the back end.
In this instance, PlayHQ fixed the issue quite quickly, but Mike says this serves as a good example of how you need to fully test code changes under peak load conditions.
I'm developing my code and I'm pushing stuff out. I'm typically doing it in Agile function. So I'm changing one bit of code. What I need to understand is how that interacts with every other part of my system that makes up this overall service I'm trying to achieve. If I'm just doing individual component testing on that one area, it could pass, everything could be green. And it's only when I put it in conditions that I'm going to start to see this. Now, again, we've talked about this one being a perfect storm. It was caused by a combination of the time of day, the fact there was more competitions on that particular date, and everything sort of rolled into one. Otherwise, it might have carried on for a few more months until we had another situation like that. So we've talked about this component testing everything through, or this functional testing, this service delivery chain. I need to test everything in context to understand it. That wouldn't necessarily pick this up, but what it would have done would identify the components within that chain itself. So therefore, again, right, I can see where that delay is. I can see the signal in this 404 error coming back. I know what's happening here, and therefore we can actually instigate, what are we going to do at this point? What can we actually do to get around this problem?
To wrap up this week's show, let's turn to the overall outage trends and what we've seen over the past fortnight.
So what we've seen is the global outages have sort of been steadily increasing since the beginning of April, really. In the second week of April, the outages rose 11%, and that's compared again to the first week there. And then in the third week of April, the number of outages increased by 6%. Now, if you look at the United States, they experienced a 4% increase in outages during the second week of April and an 18% increase during the third week. So a very similar pattern following the global trend we saw there. And what that then tells us, if we actually then look at the number of US-centric outages in relation to the total number of global outages, we saw 47% this period. I think it was around 48% last period. But again, they're sort of sitting up in that area there. Now, that is indicative then of what we've talked about previously about this ability to essentially retain or enclose the impact of an outage. So when you make a change, now again, we're not talking about sort of outages that have this domino effect because they're unexpected, but when we're doing maintenance work and we have to do something destructive, we're able to understand the impact and contain where that goes. And that's reflected in this greater than 40% figure we're seeing.
You said there was a steady increase in observed outage numbers. Is this typical for this time of year? And if so, why is that?
So it is typical. We see this pattern, and we'll be looking at this data. We've got lots of data there. We're looking at it for year over year. And again, I always see these sort of rises and falls. The outage numbers change, but the pattern stays the same. So again, as I'm coming into April, I start to see the outages numbers start to rise again. So when we talk about outages, we're talking about different provider types. We put them together here. So we have internet service providers, the ISPs, we have the cloud service providers as well. Now, when I drill into this, I can actually start to see some very interesting patterns. The numbers say sort of increasing, but I can actually start to see specifically locations that stay the same. So I can see sort of with some providers, I see a location that's the same as the previous week or the previous week before that. And then the number of interfaces that's being impacted is either grown or it's shrunk. Now, this can mean a couple of things. It can mean we're actually starting to do some expansion work at that location. So they're doing some maintenance work. But again, if I then tie that back, so talking about my multiple signals that we talked about before, I've got the same location, the same period of time, and now I've got it at a different time of day. So it may be that what this is was there was an issue at that location, it was contained, but now because we made a change, we want to make sure we sort of fix that. Or because we've gone to this out of hours or out of business hours for that specific location, we're trying to do it again. These are still outages. They still have the potential to be destructive or impact some users there. But what it tells us is they were effectively deliberately instigated. They've actually gone through a deliberate process, either maintenance, engineering, or fault resolution.
That's our show. Please like and subscribe. We really appreciate it. And not only does this ensure you're in the know when a new episode is published, it also helps us shape the show for you. You can follow us on X at ThousandEyes or send questions and feedback to internetreport@thousandeyes.com. Until next time, goodbye.